So let's make a DFA for this language W, where W has an even number of A's and each A is followed by at least one B. So we can notice initially that this is an intersection of two languages. So we can kind of underline the first language here. Let me decrease my pen size. So we can see W has an even number of A's is one language, and then we can see that each A is followed by at least one B is another language. So what we can do is we can kind of make DFAs individually for both of these and then combine them. So if we first make a DFA for W has an even number of A's, we've covered this in a previous video, but I'll do it again. So basically, if we have a initial state, let's call this state 1, right? And then we transition on A to the next state. What you'll notice is to get to this state, we need exactly one A to get to state 2, because that's the transition. On A, we go to state 2. So that means we have one A, which is an odd number. So we know that this is not valid. This is not going to be, a valid string. But if we go back on A, say we just kind of flip back to the start here, you'll notice that we need exactly 2 A's to get back to state 1. And then if we go back 3 A's and then 4 A's, 5 A's, see what's happening here? It's always going to be an odd number on state 2, but it's always going to be an even number of A's on state 1. So we can make state 1 our accept state, because we'll always have 0, 2, 4, or 6 A's in landing on state 1, and we'll always have 1, 3, you get the idea, A's when we land on state 2. You can test this if you want by, inputting different strings. If we input the string, let me create a custom string here, A. If, like on the first A, for example, say we're on the first A, we go over here on our first A, on the second A we go back, third A we go back to state 2, fourth A we go back to state 1, and then on the last A we're back at state 2, which is obviously an odd number of A's. 5 A's is odd, and we're on state 2, so that's valid, that works. So that's kind of our DFA for W has an even number of A's. Oh, we forgot to include B. So B is not really relevant here. We're not really using B anywhere, so we can just loop on B on all states. If we encounter B, basically we just want to stay in place and not move anywhere. So that's going to be our DFA for W has an even number of A's. But what if we want to create a DFA for W where each A is followed by at least one B? Now this one might be a little bit more tricky. So let's set up our initial state really quick. Let's set up our state 1 in a different color here, yellow. So we've state 1, and then let's say on transition A, we're going to go to state 2. So we need exactly one A to get here. Now our language is each A is followed by at least one B. Okay, so we know that we need an A to get here. So now what we're looking for is we need a B, or else it's not valid, right? So let's say we have another A. What's going to happen is that's not a valid string. If we have another A, that's not valid. So we're going to put it kind of on like a dead state. And then what we can do is we can loop on everything, both A and B, because we know it's dead. We know it's not going to be valid no matter what, because we had an A and then there was not a B after it. There was another A, so it's never going to be valid no matter what. So we can just put it in kind of like a dead state where it'll never accept. But what if we have an A, we transition to state 2, and then there's a B? What would we do? Well, we would go back to the initial state, because that's what we want. We want a B after an A, so we're just going to say, okay, that's fine. Let's go back to square one. Right? Now, what if we have another B after that, like the string ABB? Well, we go A, B, and then I think we should loop it on itself on B, because that's fine too. If we have ABB or ABBBBB or A followed by a million B's, it doesn't matter. We'll just be at square one, because A is kind of our condition here. If we're looking for an A is possibly the thing that could mess up this whole algorithm. So on a B, we're just going to loop in place. That's fine. We don't really mind that. And our accept state is going to be state 1 here. So now what we're going to do is we're going to kind of try and combine these two DFAs to incorporate the same exact language. So I'm going to put this in pink. So now we're kind of doing W where W has an even number of A's and each A is followed by at least one B, both of these. So what we're going to do is let's set up our initial state here. Let's call this state 1. Let me actually erase these so I can draw bigger. So now we need to find a way to combine both of these DFAs. So we're going to create our initial state. We can call it state 1. And let's kind of do this, each A is followed by at least one B DFA on kind of the x-axis first, because it's a little bit more complicated than the even number of A's DFA, so we're going to put it on the x-axis. So what we can do is, remember before we kind of put like on transition A, we go to state 2, and then on transition A again, we went to state 3. And then if it's here, then that's not valid because 2 A's in a row is not what we want at all. But now we need to track if it has an even number of A's. And you'll notice when we made that DFA, we kind of had to, switch back and forth based on how many A's we had. So what we can do is instead of switching horizontal, what we can do is we can switch kind of vertically. So if we erase these transitions here and create new A transitions, so let's also erase these two for clarity. So on transition A, we're going to go down to this kind of second row of states per se. And on this state, we know that we're not going to accept because we need one A to get here. That's kind of the same concept that we were going for before. So we're going to name this state 2, for example. And we know that we can't accept. And if there's another A after that, well, we know that we need to go to the dead state because that doesn't fit this criteria. Each A is followed by at least one B. So if there's another A after that, we can create a dead state. We'll call this state 3. And then we'll just loop on everything on state 3 because we know it's never going to accept. So we have covered A, but what about A, B? So on B, where are we going to go? So we're going to kind of go backwards here linearly, if that makes sense. So we're kind of on the second row here. So we're basically, remember the DFA we made for each A is followed by at least one B? Well, we're going to basically make two of these. We're going to make one on this kind of line here, and then we're going to make one on this line that we're making here. And then we're just going to kind of alternate between them based on the number of A's. And we're only going to accept on this top row here because we start at 0 A's, and then we will be back on this row at 2 A's. And that's kind of how this is going to go. This is one of the more complicated ones. If you've been watching other videos, this is a little bit more complicated than the other ones. So we're going to kind of go backwards on B. Say we have the string A, B. We're going to go backwards, and we're going to go to a state here. And then if we have another B, we're just going to loop on B. Because remember from the previous DFA, if we just have A, B, 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 B repeating infinitely, that doesn't change anything. So we're just going to stay where we are. But if we have another A after that, that fits this W has an even number of A's criteria. Because remember, we had A, B, B, let's say, and then another A, that's 2 A's. So when we have a second A, we're going to go up back to kind of our first row here. Oh, I've been really bad at naming my states. My apologies. I can rename these to be a little bit better. So we'll name this 1, 2, 3, 4, and 5, let's say. So then on transition A, we're going to go back up to the first row. And then what if we have a B after this? So an example string for this would kind of be A, B, B, A, B. Let me put this down a little bit. Yeah, so this would kind of be an example string. So let's go through this and kind of see what happens. So we do our first A, we go down here. Our first B, we go over here. Our second B, we loop, doesn't do anything. And then A, we go up here. And then B, where do we want to go? So this, let's see, W has an even number of A's. We have 2 A's, so that's good. And each A is followed by at least one B. And that is also correct. So what we might want to do here is, let's erase the yellow. We might want to go back to a state on B, and let's make this our accept state, right? So that kind of fits our criteria. This is a great example of a string that fits our criteria. We're going to make sure that we're on this first row of states because that means we have an even number of A's. And then when we're transitioning back to the original state on B, that means that, the A is followed by at least one B. Because to get here, we need A, B, right? And then we can just loop on B because if it's A, B, or A, B, B, or so on, it doesn't matter. So we'll just loop on B in that case. But what if, say we're here after going A, B, A, and then there's another A, well, we know that's not valid, so we want to go to the dead state here. Because, if we have 2 A's in a row, that's not good, so we're going to send that to a dead state, and it's not going to be valid no matter what. Cool, so this is the complete DFA for this language, W, where W has an even number of A's, and each A is followed by at least one B.